Good old technology. All right. So again, we're going to be graphing quadratic functions. And we talked about quadratic before in this class when we solved equations that look like this. They had an x squared in it. We had to make it equal to 0, and we factored. Okay, so that's what we're going to be graphing. And it's the x squared that makes it quadratic. That's what gives it this U shape. All right, so quadratic functions. The parent function, just like the absolute value, has a vertex at 0, 0. And then if we want to get a very accurate graph, we can pick some other x values and square them and get a y value. So if I plug in 1, 1 squared is 1, so there's a point at 1, 1. If I plug in -1 and square it, I get +1, so there's a point there. If I plug in 2, I get +4. If I plug in -2, I get +4. So everywhere I pick a positive value and square it, I would get the same y value if I square the negative. That's what makes it this U shape, and that's what makes it what we call symmetric. Okay? For every point I can put on the right side of the U, I can put another point on the left side that's has the same y value. All right, so here is our parent function, and just like from before, this point is called the vertex. This bottom point, and the vertex, that's what helps you with your shifting up, down, left, and right. Okay? Now, this U-shaped graph has a special name. Does anybody, maybe from, they taken data or something, remember what it's called? It's starts with a P. Parabola. A parabola. Okay, some people say parabola, because that's kind of how you spell it. Parabola. All right, but you'll hear it more referred to as a parabola. All right, and so that's the actual math word for a U-shaped graph. And sometimes the vertex is referred to as an extrema. Extrema. And that may be a word you haven't heard before. I'll be honest, I've never really taught it using that terminology until I teach calculus. But we have been asked to bring that terminology in. All right, and the reason it's called an extrema is because the vertex is either the lowest point, okay, on the graph, so it's the extreme, okay? So if it opens up, the vertex is the lowest point, and we actually call that a minimum, all right? And if the parabola opens down, the vertex is called a maximum, all right? But extrema is plural for min and max, okay? So just throwing in some more math terminology here, all right? Any questions so far? All right, so just like with the absolute value functions, there is a vertex form, okay? A vertex form where you can easily figure out the transformation, the left, the right, the up, the down, the flip, all that stuff, okay? And it looks like this. Y equals A times parenthesis x minus h parenthesis squared plus k. Do those letters look familiar? That thing, other than the parentheses and the square, everything is exactly the same as the absolute value when we look at it, okay? But it has to have that square there. That's not a transformation. That square makes it a quadratic function, okay? So just like we did with the absolute value, the h and the k, the left and right shift, and then the up and down shift, all right, tell me my vertex. And A will determine how the parabola opens. Okay? So that parabola will open up. So opens up if A is what? Positive or negative? What do you think makes it normal, like the parent function? A would be the number in front, well, positive, because the only thing that makes it flip down is if that number in front is negative. All right, so then it opens down if A is negative. And of course, when the quadratic function is in vertex form, like I said already, you can use that horizontal and vertical shift, that up and down and left and right, to find the vertex. Now, when we did absolute value equations, standard form and vertex form were the same thing. Okay? If you look back at the notes, I actually said standard form, also known as vertex form. But for a quadratic function, they're different. Okay? Because vertex form literally helps you pick out the vertex. All right? But that doesn't look like the ones we've solved before. All right? Because those were in standard form. Standard form is where you have y equals a x squared plus bx plus c. That's the form we've actually used when we were solving. The problem with that form is it's not very easy to find the vertex from that form. There's a lot of math that has to happen if you were going to find it by hand, and unfortunately we don't have time for that. So we are going to get to use Desmos. Okay? So Desmos is actually going to help us find the vertex. It's going to help us find the zeros, the y-intercept, and then we're going to do the domain and range and end behavior and everything. Okay? So we're going to use Desmos for everything. So you can go back and just pull up the video, skip to this part, and copy this down later. Okay? All I'm saying here is that we're going to still have to find all of these things, and Desmos is going to help us. Okay? It is exactly the same thing we were doing with absolute value. All right, so let's take a look at our first equation here, our first function. The first thing I want to know is my parabola going to open up or down? And what are you looking at to determine that? All right, so I have y equals x plus 4 squared minus 4. And yes, you could type it in Desmos if you had no idea, but think about what we just wrote down. What tells me if this thing opens up or down? The A. And the A is the number in front of the whole thing, or in front of the parenthesis here, and it's a 1. It's a positive 1. So this one opens up. Now, because this is in vertex form, I can actually find the vertex by figuring out the transformation. What does a plus 4 in parentheses do? Left 4. And what does a minus 4 outside do? Down 4. So if I start at the origin and I go left 4 and down 4, what point am I on? Perfect. So that is my vertex. Now, everything else gets a little bit harder, and it takes a lot longer to do by hand. So what we're going to do is we're going to pull up Desmos. So this is where you can actually open your Desmos, please. And I'm going to attempt to split my screen in half here. Let me pause while I figure this out. Okay, so in Desmos, the good thing about Desmos is, remember, you don't have to type the y equals. All right, you can go straight into your parenthesis stuff. All right, x plus 4. All right, notice without the square, it is not a U-shaped graph. That's why you have to have the square on it. Okay, and then minus 4. All right, so let's slide that over. All right, here's my graph. The great thing about Desmos is if you tap on the graph, or if you click on it, these gray dots appear on the important stuff. And if you tap on a gray dot, it will tell you what the ordered pair is. You just have to know what that dot represents. So the bottom one that I just clicked on is the vertex. All right, how about the 2 on the x-axis? Those are my zeros. Those are my zeros. So I'm going to write -6, 0 and -2, 0 on the line. Now, on my screen, I can't see the y-intercept, but there absolutely is one. There's always one. So I'm just going to slide my screen down until I can see where it crosses. Tap on my graph again. A gray dot appears, and when I click on it, I can get the ordered pair. So I'm going to come back over here, and my y-intercept is 0, 12. Okay? And that's all you need Desmos for. Okay? So now I'm going to maximize my other screen, and I'm going to plot those points. I already have my vertex. Now I'm going to do -2, 0, -6, 0. Do you think 0, 12 fits on this one? No. Okay, so just be careful that when you sketch it, all right, you don't look like you're going to cross the y-axis too early. Okay? And there's your sketch. Questions? Okay, now finding everything else is just like we were doing with the absolute values. Okay? Domain are what values? X's or Y's? X's. So we trace the graph from, or we look at the graph from left to right. Okay? So the left side, yes, it's pointing up, but it's also pointing to the left. So it starts at, very good. And then we look at the right end, and yes, it's pointing up, but it's also pointing to the right. So we end at positive infinity. That is the domain for every single parabola. It's also the domain for every single absolute value we looked at, right? All right, so those of you that just like to memorize something, there you go. All right, now the range, remember you're looking at the y values from where to where? Bottom to top. All right, so when I start at the bottom of this parabola, I don't have arrows. The first thing I get to is the vertex. What part of the vertex do I need? Since it's the range. The y value. They happen to be the same here, but so we're going to start at -4 with a bracket. And we're going to go up to what? Infinity. Good. All right, end behavior. How many ends do we have? 2. And they're both arrows. We have one on the left and one on the right. So for my x, in the x spot, I need one negative infinity and another positive infinity. So one of them needs to be negative infinity, one of them needs positive. Which one needs left? Which one means the left? No, I'm sorry. Which one of these means the left? One means left, one means right. Nobody knows what I'm talking about? All right, when I do end behavior, right, I'm talking about this arrow means as x goes out to negative infinity. Okay? Well, for the x value of negative infinity, is that the left or the right side of the graph? That's the left. Okay? So when I put negative infinity there, I'm talking about I'm looking at the left side or the left end. And when I put positive infinity, that means I'm looking at the right end. Okay? Now the y spot is all about, is it going up or down? Well, both of these ends are going up, So both of those need to be what sort of infinity? Positive. If this was a down parabola, they would both be, come on guys. If this was a down parabola, what would go in the y spots? Two negative infinities. Okay. Then I do my increasing and decreasing intervals. Right? So I'm doing this because if you were struggling with absolute value, this is a good review. This is a good help for that. All right? You're going to start on the left and trace your graph towards the right. What am I doing first? Decreasing. And we always start at negative infinity. Just make sure you put it on the decreasing line. And when do I stop decreasing? When I get to what? Not, I don't want the number yet, just what's that point called? The vertex. Okay, so I stop decreasing when I get to the vertex, but don't forget these are x values. Okay, so I would stop at -4. Oops. All right, and then what happens after the vertex? What am I doing? Increasing. So I start at the vertex and increase to the right forever. Questions? Okay, so let's see. I am going to, do we have enough time? How many do I have on here? 2, 3, 4. Yeah, okay. So I'm going to pause the video or the recording and give you a chance in the next 5 to 7 minutes to try number 2 on your own. Okay, hopefully you were able to get everything that I've done so far straight from Desmos. Okay? Just make sure yours looks something like the one on Desmos when you graph it. Okay? All right, what's the domain of all of these U-shaped graphs? Where does it start and where does it end? Thank you. To positive infinity. Perfect. Okay? All right, my range. This one opens down for a change. So where does my range start? Negative infinity. And it stops at my vertex. Just don't forget it's the y value of your vertex. Whoop, I said it and then didn't write it. And you use a closed bracket. That's the only one that should have anything squared off. Okay? End behavior. I have a left end, so I put negative infinity in the first blank, and I have a right end, so I put positive infinity in the blank under that. Left and right go with the x. Okay? Now, both ends are pointing down, so what goes in both y spots? Negative infinity. Good. And then when I trace from left to right, what's happening first? Increasing. So the increasing interval starts with negative infinity. Whichever one you do first, you start with negative infinity. And then you stop at the x value of the vertex. All right, and then what's happening second? Decreasing. So I start again at the vertex, and I always go to positive infinity. So I'm not talking about going down. I am because I'm decreasing, but I want to know where am I going to the right. Okay? So whichever one happens first, you start with negative infinity. Whichever one happens second, you end with positive infinity. Never mix them up. Okay? All right, so then the other two that I have for us to look at, they are just in standard form as opposed to vertex form. So you absolutely need Desmos, all right, to help you find all of this information. Okay? The vertex, the up or down you could probably do without. All right? What number's in front of x squared? a 2, and it's positive, and that's your A. All right, so this one opens up or down? Up, okay? The rest of it, I would absolutely use Desmos to find the vertex, the zeros, and the y-intercept. Okay? All right, so take a few minutes and work on that one. Okay. So hopefully you got the right vertex, zeros, and y-intercept. Again, you got all that from Desmos, so hopefully we're all on the same page. And then when I plotted those points, all right, I actually plotted an extra point on mine. Anybody know how I might have gotten the point in red that I plotted? So it's at 1, 2, 3, 4, 6. Anybody know how I might have gotten that one? Correct. Okay, so the idea is that because these graphs are what we call symmetric, they have equal points on each side. So I just figured out, like, if my vertex had an x value of 2, so I kind of like thought about going up from there, I just figured out how far away the y-intercept was on the left and put another point on the right the same distance away. And so it just makes my graph look nicer. Okay, so just a thought there if you're having trouble drawing a fairly decent graph. Okay, all right, so what's the domain of all of these quadratics? Somebody new, somebody different. The domain, they all, left to right, they all start at and go to, very good. Okay, somebody else, help me with my range. All right, I start at the bottom. -2 with a bracket and go up to positive infinity. Good. All right, somebody different. End behavior. I have a right and a left, yes? Okay, so what do I need in one of the lines next to the x? What? Did somebody over here say it? What goes in one of the blanks next to the x? A negative infinity. And what goes in the other one? Okay. You have to have one negative and one positive next to the x because you always have a left and a right. All right, now next to the y's, they should match each other because both ends are doing the same thing. These are going up. So what goes in the y spot? Positive infinity. All right, now when I trace my graph, start on the left, trace it with your finger. It's going what? Down or up? Down, so it's decreasing first. You always start at negative infinity. And you stop decreasing when you get to the vertex. Do I use the 2 or the -2? The 2, because these are x values. And then the other one has to start at the same spot. And you always go to the right. So you always end the second one with positive infinity. All right, and then there is one more in the notes, and I'm going to tell you the vertex. I want to tell you a lot of the stuff real quick. This one actually opens down because the number in front of the x squared is technically the a, and it's negative. Okay, the vertex on this one is 0, 1. And if you were to type it in Desmos, it would not cross the x-axis at all. So we just write none right here. Okay? Well, didn't we talk about that earlier? That could happen with a v. That could happen with a parabola as well. Okay? There's always going to be a y-intercept. All right? So let's plot it. 0, -1 is the only point that I can plot. All right? So then you might want to, take advantage of Desmos and zoom in and see if you can find any more that look like they go perfectly through a grid mark. because this one actually has a point at -1, -3, and +1, -3. Again, I just got those off of Desmos. Ooh, that's sloppy. Come on. Make sure it's curved and not a sharp point. Okay? All right, what's the domain of all of these? Very good. -infinity to +infinity. All right, somebody different that hasn't spoken much today. All right, where does this range start? If it has arrows pointing down, where does it start? -infinity. And where does it stop? Where does the range stop? All right, it stops at the vertex. Which value do I use, the 0 or the -1? The range on the y's, -1. Okay? Kevin, I need to hear from you. Grady, I need to hear from you. Somebody help us out. Chance, I need to hear something from you today too. Brooke, you too. All right, so Grady, for my end behavior, next to one of the x's, I need what? An infinity. That's the right end. Kevin, what do I need next to the other x? The one up here. I would never put a 0 there. What represents the left side of the graph that keeps going forever to the left? Okay, so again, I cannot stress this enough. You need one of each next to the x, always, for everything we've been doing today. B's and U's, right? Okay, now both of these are pointing down. So Brooke, what goes in these two spots? Negative infinities. What if they were going up? They would both be positive infinities. Okay? Chance, what am I doing first when I trace it from left to right? What am I doing first? Increasing or decreasing? Increasing. And my first interval always starts with, I'm talking about left to right. What's the most thing left that I can write down? Okay. And then we stop at the vertex. Keith, what's the x value of the vertex? No, the x value. 0. And then from the vertex, I decrease, but I always end with what infinity? Positive. Positive. We're going from left to right. I don't care that I'm pointing down, okay? That's the whole decreasing part. But those are the y values. I want the x values, so we're going to the right. All right, so what is your homework?